let's take a look at some more exponential explicit growth models. According to the United States Census Bureau, the population of Utah was 2.12 million in 1997 and 2.53 million 9 years later, so 2006. Use this explicit growth model to calculate the rate of growth over this time period. Express the rate of growth as a percentage rounded to the nearest 100th. Okay, great. So what we need to see is the initial value, the prior value, and the after value, after specifically 9 years. We have everything we need except for R, and that's what we're trying to find, calculate the rate. So plugging the numbers in that we have, we would have 2.53 equals 2.12 times 1 plus R to the 9. Now the 9 can be seen if you do 2006, subtract 1997. That's the way that you could find out that 9 years had passed if they don't give you the 9 and instead just provide you with the before and after dates. Just subtract them, you can see how many years have passed. Okay, so now we need to figure out how to solve for R. Well, first off, I can divide by the 2.12 and peel back one layer of this expression. And I'm not going to evaluate this left side because I don't want to make any rounding errors. Now, how do we get rid of the 9 power? There's basically two things. One would be a 9th root. But that begs the question, how do we do a 9th root on our calculator? So instead of the 9th root, I prefer to write it as a 1/9 power, because then that's something I can do on my calculator without knowing any fancy buttons. This works because when you raise a power to a power, you multiply, and 9 times 1/9 is just 1. So we end up with just 1 plus R. The right side is just getting a little bit more and more messy. The last step is to subtract 1 from both sides. And so that would give us R equals. This is the exact value, no rounding at all. This is how far you want to get it before you go to your calculator and get an approximation. So let's take a look at the calculator now. So we have parenthesis 2.53 divided by 2.12 close parenthesis. This is to the power 1/9. We can do this in a couple of ways. Power button, parenthesis 1 divided by 9. That's a very safe approach. Let's just stick with that. And then subtract 1. This is the number we're looking at. However, it says round to the nearest 100th of a percent. So you need to get to percent first. If you multiply by 100, you're now looking at the percent. This is what we want to round to the hundredths. So notice the 8 is in the hundredths spot. Whereas before we convert it to a percent, you would see the 1 in the hundredth spot. And we're not asking to round to that spot. We're asking to round to the 100th of a percent. So get to percent, then do your rounding. This is 1.98% rounded. All right, that's the growth rate. So what we see, a nice little alliteration in these exponential models. To find the rate, use a root, which I'm writing as a fraction exponent. Okay, go ahead and pause the video and work out question number 10. what you should get is R is approximately 21.4%. All right, I hope this helps. Let me demonstrate with our calculator a way to check this. So if we start off with 5,400 and then we multiply our answer by the growth factor 1 plus R, which is the 21.4 over 100, this should grow it by the growth rate once. So this is 1 year later, 2 years later, 3 years later, 4, 5, 6, and 7 years later. We're just about at 21,000. The reason why we're not at 21,000 is we've rounded the growth rate. But this is so close to 21,000 that I feel confident that this is the correct rate. Using your answer button, you can do exponential, linear, and logistic growth just by simulations like this. Okay, excellent.